Hello and welcome students. So now let's start exercise 2.2 question 2. Now in this question again we have to find a quadratic polynomial whose sum of zeros and product of zeros is given. So as we have seen in the previous video that the easiest method, the simple method is x square minus sum into x plus product. So this is just the perfect expression. We put the values, substitute the values, and we'll get the answer. But here we are trying to understand why and how the things are being done. So we are not doing it without understanding the reason. So first of all, there are infinite quadratic polynomials. You have to always understand that whenever sum and product of zeros is given, then the possibility is that there are infinite quadratic polynomials that can be found. But the question, as you have seen, the question does not say find the. So there's not one specific, there are many possible and you have to just give one. So when we have to find one only, that means we have to find the simplest and the most standard form of the quadratic polynomial, that is ax square plus bx plus c. So here we'll try to find it out just by substituting in this expression. So x square minus the sum of zeros is root 2 into x plus the product of zeros is 1 by 3. Now we have got the simple quadratic polynomial, but we see that it is not in the standard form. The standard form is ax square plus bx plus c. It is not it does not look like in the standard form. So we will try to remove the numerator 3, the denominator 3, that is 1 by 3 part. So what we do, we equate is equal to 0 because it says these are zeros, and what does the 0 do? The 0 changes the entire expression into equal to 0. So when we put equal to 0, it becomes a quadratic equation. The moment we put equal to something, it becomes an equation. So now since the value of the entire polynomial is now 0, so we can multiply with any number. Its value will remain 0 only because when we multiply anything with 0, the value does not change. So here, because we have to remove the 3 is in the denominator. To remove it, we have to multiply 3 in the numerator, but we cannot do it only on one side. We have to do it on both the sides. That is the rule. So when we do both the sides, it becomes equal and also it becomes 0, so it does not change. So 3x square minus 3 root 2x plus 3 by 3 multiplying by 3 and equal to, this side will remain 0 because 3 into 0 is 0. Now 3 and 3 get cancelled, so we have 1. So we don't need the equation, so we will not write equal to 0. Now we will remove the 0 and we will write 3x square minus 3 root 2x plus 1. So this is the final answer without writing 0.